Okay, so these are the last two problems from the study guide relative to chapter 26. The first one is number 35 over here, and the text is the following. A large reflecting telescope has an objective mirror with a 10-meter radius of curvature. What angular magnification does it produce when a 3 centimeter focal length eyepiece is used? So the things that you want to have in mind is the following. You have this mirror which collects the light, so I created some sort of like two rays. It goes to a focal point they call FO, the objective focus from the lens, from the mirror. And then we have a lens. Okay, so here's the lens. They receive the ray from the mirror, and the image is projected over here. Okay, so what we want is the angular magnification. Okay, so what do we know about this problem? Well, we have the radius of the radius of curvature of the mirror is 10 meter. We know the focal length of the eyepiece, there is a little e over here, the focal length of the eyepiece is 3 centimeters. So we know that the focal length of the mirror for spherical mirror is r1/2, so half of the radius of the curvature. So in this case, FO, the focal length of the mirror, again is the focal length of the mirror, which I didn't draw, but just not confused, but the distance between the focal point and the mirror itself, is 5 meters. And now we can define the magnification, okay, and the magnification is minus FO over FE, which is equal to minus 5 meter over, again, 0.03 meters. So I change the centimeter to meter, and we get a magnification of negative 166.7, which is the image that we see is magnified of 167 times, and it's going to be inverted. Okay. The last problem of this chapter is the number 36. So in this case, we have a small telescope with a concave mirror with 2 meter radius. So here's your mirror over here. The radius is 2 meter. I didn't draw the radius there because it is already complex as it is. The eyepiece is a 4 centimeter focal length lens, which I just draw over here. And the first question is, what is the telescope's angular magnification? So very similar to the problem that we have over here. So the angular magnification M is minus FO over FE, which is minus r1/2 over FE. So plug in the numbers. I have 2 meters for the radius. This number 2 comes from the top, times the focal length of the eyepiece, which is 4 centimeters, so 0.04 meter. And we get a magnification of minus 25. Okay, that's the first part of the problem. The second question is the following. What angle is subtended by a 25,000 kilometers diameter sunspot? Okay, so what does it mean? It means that we are looking at the sun, which is really, really far away. Okay, and on the sun there is a sunspot, a region that is darker than the rest. And here's the diagram that you want to have in mind. So understanding this distance d is this between Earth, this point, and the sun over here, the sun surface. Okay, the thing that we want to observe is long d, which is the length over here on the side, which I split it d1/2 and d1/2. Okay, and I did that for simplicity. Okay, so look what's going on here. The angle subtended by this side of the triangle is theta, right? From this point here to that point there, the angle is theta. Half of that theta is alpha. Okay? All of this geometry will come handy in a second, okay? Look at this. This is a right triangle, Earth, the surface of the sun, and this point over here. And the angle here is alpha. So for small angle, well, by definition, we saw the tangent of this angle alpha is this side of the triangle divided by this side of the triangle. So it's d1/2 divided by the distance Earth to the sun. And so the angle alpha is the arctangent of this number over here. So the angle alpha is the arctangent of 2.5 times 10 to the 7 meter divided by, sorry, it's half of that because the full size is d, which is 25 kilometers, 25,000 kilometers. So I'm dividing that by 2, and then divided by the distance, which is 1.5 10 to the 11 meter. That's the distance between Earth and the Sun. Okay, this big D over here. So if you plug in these numbers, you're gonna get that the angle alpha is 4.77 10 to the minus 3 degrees. What is the angle subdued by the whole thing? Well, the whole thing is just twice as much. So the angle theta is twice alpha, and that number is 9.55 times 10 to the minus 3 degrees. Okay, that's the answer to number 2. What angle is subtended by 25,000 kilometers diameter sunspot? The third and last question is, what is the angle of its telescopic image? Meaning, when I'm looking at how big is this angle? Well, we know that the magnification of this telescope is minus 25. And the magnification is equal to the angle observed, okay, the angle on the image, divided by the actual angle in